Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical which is there in work, energy, power part A. Before solving any question, my suggestion is you have to watch the theory concept. Okay, if you learn the theory concept properly, then you can aramse solve all the numericals. So we have made that video and we have solved each and every theory question which is there in your textbook. Exercise part, theory exercise part, we have solved it, and that video is also available in the description box. If you watch those two videos, then this numerical video will be very useful for you. We are going to use whatever the things we have learnt in theory part. Before solving our first question, we need to understand few important things. First, formula. Work done formula. Work done is equal to Fs cos theta. F is nothing but force, S is nothing but displacement, and cos theta. See, you need to understand when we have to use this cos theta, when we should not use this cos theta. Listen, if an object, okay, assume there is an object and I apply force in this direction. If the object moves in the same direction, okay, the force direction and the displacement direction, if both are same, then we don't have to use this cos theta. Then work done will be just Fs. Okay, you can use cos theta also for this condition. See, if there is no change in the direction, what will be the angle? What do you mean by theta? Theta is nothing but an angle. Which angle is that? The angle between force and the displacement. If both are in same direction, then angle will be 0. What is cos 0? Cos 0 is equal to 1. So whatever the value we have, if you multiply with 1, we are going to get the same value. So instead of using cos theta, if it is in the same direction, you can use only Fs. That's it. Now, if there is any change in the direction, if you are applying a force in this direction and if the object is moving in this direction, any direction apart from the same direction, any direction, then the theta value will be given in the question. Theta value will be given in the question. See, theta value will always be standard values. You have learned the trigonometry. In trigonometry, there is a table, angle table, right? Sin 0, sin 30, all those things. Here we are going to use only cos values. Cos 0, cos 30, cos 60, cos 45, cos 90, cos 180. All these values you should know, only cos theta. So once you know that, the theta value will be given, substitute here, okay, then whatever the value, force and displacement is given, multiply with that cos theta value, then we will get the work done. Next, okay, we have to focus more on units. See, work done unit will be joules, or you can write it as Newton meter also. So mainly you focus on joules. Next, force unit should be Newton. Okay, in many questions they are going to give you mass or weight of an object or any person. Okay, see, mass or weight of an object or any person. We have to convert this mass or weight, any one. Okay, they will not give you both, any one. We have to convert that into force. In few questions they will mention the value of gravity. It may be 10, it may be 9.8, whatever the value they are going to give. If they give you G value as 10, then whatever the mass value we have, mass or weight value we have, that into 10 we will get the answer in terms of Newton. Okay, you got my point. I'll give you an example. Okay, 20 kg is the mass of a boy. Then we have to convert this kg in terms of Newton. How we can convert? Into 10. Okay, this value sometimes they will give in the question. If not, you have to assume it as 10. Okay, G value is nothing but this 10. In some question they will mention G is equal to 9.8. Then instead of taking 10, you have to take 9.8. If kg or kgf both are same, don't worry about it. This is the unit of mass, this is the unit of weight. 1 kg is equal to 1 kgf. So whatever they have given, 20 kg or kgf, you multiply with gravity value, G value, we will get the answer in terms of Newton. Then distance, see, sometimes they will give you h, height. Okay, height is nothing but displacement. You can take any one. If they have mentioned height as 8 meter, then that is nothing but S is equal to 8 meter. Make sure it is in meter. So what are the important things? First, when we have to use this cos theta, when we should not. You can use it for all the cases, but make sure you are calculating the value. If the theta value is 0, okay, then cos theta is 1. If theta is equal to 90 degree, then cos theta value will be 0. Anything multiplied by 0 will be 0. So work done will be 0. Make sure you are getting the proper theta value. Then units of everything. Force. This is very much important. Why? Because in most of the questions we are going to convert mass or weight in terms of Newton, then we are going to substitute in the formulas. So before substituting the values, make sure it is in SI units. All these are SI units. So if we know all these things, then aram se we can solve any question. Question number 1. A body when acted upon by a force of 20 kgf gets displaced by 1 meter. Calculate the work done by the force when the displacement is in the direction of force. Second one, at an angle of 60 degree with the force and normal to the force. First we'll write what are the given data, then we can aram se solve the problem. So what is given? Weight. kgf is a unit of weight. Here we are not going to use W because that is what we are going to use it for work done. We'll call it as mass. Mass is equal to 20 kgf. See, remember one thing, for given data you are not going to get any marks. But why we have to write the given data means you will understand what we are going to find and what is the formula required. So if we write it properly, then we will get the proper answer in your brain. So mass is given, then displacement as 1 meter. We have to find the work done in 3 different conditions. Okay, first we'll talk about the first one. What is the first question? Find the work done in the direction of force. What is that? The displacement is in the direction of force. Okay. First we will write the formula. W is equal to Fs cos theta. See, if force and displacement both are in the same direction, then we don't have to use this cos theta. Okay. If both are in the same direction, cos theta will be 1. Why? Because if both are in the same direction, theta value will be 0. What is cos 0? Cos 0 is equal to 1. Then we have to use Fs 1. So instead of using cos theta, we can neglect it only if it is in the direction of force. Now what is the value of force? Force value is not given in the question. During the introduction of this video, I told you if force is not given, we have to convert mass or weight in terms of force, correct? How can we convert this value in terms of Newton? What is the G value they have given? G value they have given as 10. Don't worry about the units, you will get confused. Just understand what is given. Okay, G value is 10, correct? Don't worry about the unit. So what is the mass value? That is 20. Whenever you multiply mass with G, that will become force. Whenever we multiply mass with G, that will become force. So 20 into G value. So these two are completely related to F. Then we are going to write S value. What is the S value? 1 meter, correct? Then cos theta is equal to 1. So 20 into 10 into 1 into 1. So that is nothing but 200 joules. That's it. Very simple question. See the second one. In the second one, they have given theta value. So theta is equal to 60 degree. Okay. If theta is equal to 60 degree, then what is cos 60? Cos 60 is equal to 1 by 2. Correct. 1 by 2, that is nothing but 0.5. So whatever the value we got for cos 60, we are going to substitute in the same formula to get the answer. Again in this question we are going to find work done. W is equal to Fs cos theta. So F is 20 into 10, that remains same. S is again 1. What is cos theta? Cos theta is nothing but cos 60. What is cos 60? That is 0.5. Okay. Then 20 into 10, 200, 200 into 0.5. Any value, when it is multiplied with 0.5, whatever the value we have, that becomes half of it. So what is the half of 200? That is 100 joules. That's it. Next, third question. Again we are going to find work done, but they have given one condition. What is that? The displacement is normal to the force. Normal to the force. What do you mean by normal? Normal is nothing but perpendicular. When it is perpendicular, that means, listen, the force is applied in this direction, displacement is in this direction. See, this is called normal or perpendicular, both are same. When it is normal or perpendicular, angle will be 90 degree, correct? This is very much important. See, in the third question also they can aramse give angle value, theta value, correct? But they are using keyword. What is that? Normal. Normal or perpendicular. If they are using any one of these word, that means theta value will be 90 degree. For normal, okay, normal, that implies theta is equal to 90 degree. If theta is equal to 90 degree, what is cos 90 degree? Cos 90 is 0. Cos 90 is 0. So in the first question, listen, object is moving in the same direction. I am applying force in this direction. See the question, it is in the direction of force. The displacement is in the direction of force. If both are in the same direction, the angle will be 0, correct? Here there is a angle that is 90 degree. Here if both are in the same direction, angle will be 0. What is cos 0? Cos 0 is equal to 1. That is why here I have written 1. So in the same way we have to write the formula. W is equal to Fs cos theta. F again 20 into 10 into 1. What is cos 90? Cos 90 is equal to 0. Anything multiplied by 0 will be 0. In all the three cases we have found work done. Listen, instead of substituting this 20 into 10 in all the cases, we can aramse find force value in the beginning itself separately, so that we can substitute in all the conditions. Question number 2. A boy of mass 40 kg climbs up the stairs and reaches the roof at a height 8 meters in 5 seconds. Calculate the force of gravity acting on the boy, the work done by him against the gravity, the power spent by the boy. So here the value of G is given as 10. So first we will write the given values, then we can aramse find all the questions. First one, so mass is given. Mass of a boy is 40 kg and he has reached the height of 8 meter. Height is equal to, in the beginning itself I told you, height you can take it as displacement. So height is nothing but S only, that is 8 meters. Then time 5 seconds. G is equal to 10, correct? Now what are the things we have to find? F, W, P. See, this is why I tell you, you have to write the given data beginning only. Then aramse we can find what they are asking. So first we need to find force. Okay, first one we need to find force. So here how to find force? We have mass and gravity, correct? Force, what is the force formula? Mass into acceleration due to gravity, correct? So M is equal to 40 into G value they have given as 10. Don't worry about unit of G. Okay, sometimes they will give you 10 or 9.8. You only focus on that value. Whatever the value they have given, we have to substitute here and get the answer. So 40 into 10, that will be 400. What is the SI unit of force? Newton. Very important thing is Newton. For every wrong unit, they will deduct 1 mark. In one question, assume there are 4 different calculations, 4 different values you are going to find. If in all the 4 cases, if all the 4 units are wrong, you are going to lose all the 4 marks. If the question is only for 4 marks and all the answers are correct and all the units are wrong, you are going to lose complete marks. So SI units are very, very important. Next, second one, we are going to find work done, correct? Work done formula is equal to F S cos theta. Okay, in this question, okay, they have not mentioned anything about theta or angle, correct? They are not telling it is in the direction or somewhere, or they have not given the angle value, correct? Then we can neglect this one. Okay, then what is the value of F? That is what we have found, 400 into S. Height is given, height is nothing but displacement, so that is 8 meters. 4 8s are 32, 2 zeros, I'll write it as it is. What is the SI unit of work done? That is nothing but joules. Third one, we need to find power. What is the formula for power? Power is equal to work done by time. See, in all the questions I am using short forms, P, W, T. In the exam you have to write it in the full form. If you write like this, you are not going to get any mark. So write it in the full form. W, that is what we have found, 3200 divided by time. Time value they have given as 5. So this is nothing but 5 ones are 5 6 are, this will be 640. What is the SI unit of power? Watt. That's it. See, if you know the formula and if you can convert what are the given values in their SI units, then applying the formula, substituting the values, getting the answer with proper SI unit. That's it. Question number 3. A man spends 7.4 kilojoules energy in displaying a body by 74 meter in the direction in which the force applied in 2.5 seconds. Calculate the force applied and the power spent in HP by the man. Very simple question. Okay, first we will write what are the given data. A man spends 7.4 kilojoules. So 7.4 kilojoules, what is that? That is nothing but work done. So that is 7.4 kilojoules. Okay, K should be in small letter, kilo. Next, the height is given. Height is nothing but displacement, that is 74 meter. Then we need to find force and power spent. We need to find force and power spent, that too in terms of HP. Don't worry about this one, I will teach you at the end. Very simple thing, just a conversion, whatever the value we are going to get, convert it in terms of HP. That's it. First we will find the value of F. Okay, see, they have given work done and S. We have to find F. What is the formula? Work done is equal to Fs. Here again in this question they are not going to talk about any angle, or they are not given any hint like it is normal or it is perpendicular. So we can aram se neglect this cos theta. We don't have to use this one to find F. So that will be Ws, correct? F is equal to W by S. So F is equal to, what is the value of W? That is 7.4 divided by 74 into 10 power 3. Why I have written 10 power 3? K, kilo. Kilo means 1000. 1000 we can write it as 10 power 3. If we simplify it, 7.4 into 1000, that is 7400 divided by 74. That is nothing but 100 Newton. So we found the value of F. Correct. Second one, see, whenever you find some value, okay, in any question, in any numerical in physics, once you find the answer, just write the conclusion. Therefore, force applied is 100 Newton. If you write like that, then if I am the person who is correcting your paper, I'll see this one, I'll give you full marks. Why? We are not going to see all these things. But see, if you don't write the formula, they are not going to give you any marks. But for formula, there is no marks. This is the logic. You need to understand. See, don't worry about it. It is not a controversial thing to talk. Just write the formula, and formula should be in full form. Once you write the formula, substitute the values, get the answer with a proper unit. Once you get that, write the conclusion. Therefore, force applied is 100 Newton. That's it. Next, first we will find the power, then we will convert into HP. What is the power formula? Power is nothing but work done by time. What is the work done? They have given 7.4 kilojoules, that is nothing but 7400, correct, divided by time. So in this question they have given time, correct? Time is equal to 2.5 seconds. So we are going to substitute here 2.5. So 7400 divided by 2.5, that will be equal to 2960 watt. 2960 watt. So we don't want the answer of power in terms of watt, we want it in HP, correct? So 1 HP is equal to 746 watt. If you want to convert watt in terms of HP, whatever the watt value you have got, divide that value by 746. So whatever the value you have got, that divided by 746, we will get the answer as 3.97 HP. That's it. See, in the exam, when you got the answer in terms of decimal, and one important thing, never ever keep any answer in terms of fraction. Okay, if you keep the answer in fraction, then forget about the marks. All the answers should be kept in decimal form, and in decimal form, after this decimal point, 2 digits are enough. If you are getting recurring or non-recurring, anything is fine. So if it is you are getting 3.96, that is also fine. So first thing is this value, after the decimal first value, then this value you can round it off or you can keep it as it is. What we want after the decimal value, we need 2 digits with a proper unit. That's it. See how simple is this? We know the formula, we are getting the answer in proper SI units, and we are writing the conclusion. You have to write the conclusion. Therefore, power spent by the man in terms of HP is 3.97. That's it. Question number 4. A weight lifter lifted a load of 200 kg to a height of 2.5 meter in 5 seconds. Calculate the work done, power developed by him. Take G value as 10. So first we will write what are the given data. A weight lifter lifted a load of 200 kg. So we can take that weight as mass 200 kgf. Why we are using as mass? Because just to avoid confusion between W. If we take W here, work done, again we are going to take W, just to avoid the confusion. For given data, don't worry about it. If it is wrong also, they are not going to deduct any mark. So M is equal to 200 kgf. Then time is given and height is also given. Height we can take it as displacement, that is 2.5 meter in 5 seconds. So time is given 5 seconds. What we have to find? Work done and power. Work done and power. See, write like this, then we will get the answer directly. For work done, what is the formula? Work done is equal to Fs cos theta. Again in this question, they are not talking about any angle or that word perpendicular or normal. So we can neglect this one. In the exam, don't write this one. Just write Fs. If they are talking about, okay, if they are talking about angle or it is normal or perpendicular, then we can write it as cos theta. Now we don't have the value of F, correct? F we can take it as mass into gravity. In this question they have given G value as 10. Don't worry about the unit again. So force is nothing but mass into acceleration due to gravity, that is 200 into 10. Then S value, that is nothing but 2.5, correct? So 200 into 10, that is 2000. 2000 into 2.5, that is 5000 joules. That's it. So write the conclusion. Therefore, work done by the person is 5000 joules. Next one, we have to calculate power. Power is equal to work done by time. Work done is 5000 joules by what is the time? Time is 5 seconds. 5 ones are 5000, correct? So that is 1000 watt. If they are asking the answer in terms of HP, whatever the value W, okay, watt value we have got, that divided by 746, we will get the answer in terms of HP. But in this question they are not asking, so 1000 watt is our final answer. Question number 5. A machine raises a load of 750 Newton through a height of 16 meter in 5 seconds. Calculate the energy spent by the machine, the power of the machine if it is 100% efficient. Okay, in this question they have given 2 different things, but you should not get confused. I will teach you how to identify the given data. Okay, here they are asking you to find energy, correct? Energy, whenever they are asking the value of energy, you will get confused whether we have to find energy or work done. How to identify it? First we will write the given data, then I will make you understand it. Okay, a machine raises a load of 750 Newton. Force is directly given, 750 Newton. Then height, that is nothing but displacement, is 16 meters. Time is given as 5 seconds. Now we have to find energy and power, correct? So here we are not going to find the value of energy, and power we should find if the efficiency is 100%. Okay, energy we are not going to find energy. Why? Because energy in this question means work done. then how can we identify whether in all the questions whether they are asking energy or work done? That depends upon time. If the time is given in seconds, okay, very important thing, if the time is given in seconds, then they are talking about work done. If they are asking energy, or if they have given the value of energy, if the time is in terms of second, that is the value of work done. Here they are asking energy, that is nothing but work done. Then if they are asking energy, real energy value, not the work done, then time value will be given in terms of hours. That's it. So this is how we will find whether they are asking energy or work done. Okay, now listen, first don't worry about this 100%. I will teach you one method. Okay, first we will find energy spent by the machine or work done by the machine. Both are same. W is equal to F into S, correct? Don't worry about cos theta because they are not talking about any angle or normal or perpendicular. So direct question, then F value is 750 into S. S is nothing but height, that is nothing but 16. So 750 into 16, that is nothing but 12,000 joules. That's it. So once you get the answer, therefore work done by the machine is 12,000 joules. Done. Second one, power. What is the formula for power? W into T. Correct. Now we'll talk about this percentage. Okay. If they are talking about 100%, then multiply whatever the value we are going to get into 1. If the machine is 100% efficient, then whatever the value we are going to get from this formula multiplied by 1. Okay, this 1 will tell us it is 100% efficient. Work done value 12,000 divided by time. Time is given as 5 seconds. So 12,000 divided by time, that is nothing but 2,400 watt. Into 1 we are going to get the same value. Question number 6. An electric heater of power 3 kilowatt is used for 10 hours. How much energy does it consume? Very simple question. In this question there is a hint. First we will write the given data, we will understand them. Okay, power they have given as 3 kilowatt. Okay, next time they have given as 10 hours. Then we have to find the energy, okay, in terms of kilowatt hour and joule. Okay, first we will find the answer in kilowatt hour. We will apply the formula, whatever the value we are going to get, that will be in kilowatt hour only. Then we will convert that value in terms of joules. Okay, so here in this question, are they talking about energy or work done? In previous question they were talking about work done even though they are talking about energy. So how can we find that? See, in this question time value is given in terms of hours. When it is given in terms of hours, then they are talking about energy. If the time value is in terms of seconds, then they are talking about work done. Don't get confused with the word energy. Okay, you can easily identify with the unit of time. Okay, now energy, we have to find the value of energy. Energy is equal to power into time. This is one formula. Okay, very easy formula. In this chapter all the questions are very easy because the formulas are very easy. You just have to find the angle between the force and the displacement if they have given. Okay, that is the only tricky part you are going to find. Apart from this, everything is direct. Okay, now they have given power in terms of kilowatt. Okay, write that value as it is, then you will understand why. Okay, so 3 kilowatt into time is given as 10 hours, correct? In all the question we were not used to write the units, but in this question we are writing it. Why, you will understand here. 3 into 10, 30 kilowatt hour. Okay, see the question properly. We have to find the energy in terms of kilowatt hour. We got kilowatt from power, or we got it from time. That's it. So 30 kilowatt. Now they are asking the same answer in terms of joules. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. This is the conversion we require to find the answer in terms of joule. 1 kilowatt hour is equal to 3.6 into 10 power 6 joules, correct? So 30 kilowatt hour is equal to 30 into 3.6 into 10 power 6 joule. 30 into 3.6 we will get 108 into 10 power 6 joules. In few textbook, so if you keep it like this, you will get the full marks, complete marks. In few textbook, they will write it as 1.08 into 10 power 8 joules. See, you can keep it like this or this, anything is fine. In the textbook, they have given like this, but don't get confused with the power value. Both, if you write any one, you will get full marks. But the units, the proper unit is very much important. Question number 7. A water pump raises 50 liters of water through a height of 25 meters in 5 seconds. Calculate the power of the pump required, assuming it is 100% efficient. Take G value and density of water 1000 kg meter cube. So many things are given, don't get confused. First we will write what are the given data. So 50 liters of water. What is that 50 liters of water? Do you think that is mass or weight? No, it is the volume. Whenever we talk about liquid, that 50 liters, all those things are volume of the liquid. So volume of the liquid is 50 liter. Then height is given, correct? Height is nothing but displacement, that is 25 meter, and time they have given as 5 seconds, and G value is also given. G is equal to 10. Don't worry about the unit. Now again, density of water. Okay, density of water is equal to 1000 kg per meter cube. Okay, so what we have to find? We have to find the value of power, and we have to assume it is as 100%. This question might look tricky, but if you know the method how to derive the formula in the numericals or anywhere, it is very easy. I am going to teach you how to do it. Very simple. Listen, first write the formula for power. That is what we are going to find, right? First write the formula for power. Power is equal to work done by time, correct? Now, do you think work done value is given? No. So first we will find the value of work done. How we can find the value of work done? Force into displacement. S value is given 25 meter. We don't have force. How to find force value if it is not there? Mass into G value, correct? G value is given. We don't have mass. So first we have to find, okay, this mass. This is how we are going to derive the formula, okay, from the given data. First write what we have to find. Power. What is the formula for power? Work done by time. We have time, we don't have work done. We will find work done. What is the formula to find work done? Work done is equal to F into S. S is given. We don't have F. How to find F? F is equal to mass into gravity. Gravity value is given. We don't have mass. Now we have to find mass. Okay. This is our first step. How to find mass with the value? We have density value also. What is density? Density is equal to any density. Density is equal to mass by volume. We have density and we have volume. We can aram say find mass, correct? Mass is equal to whatever the density value, that into volume. So density is 1000. Okay, then volume. Volume, if you take it as 50 liters, then whatever we are going to find, everything will be wrong. See here, what is the unit of volume? It should be in meter cube, correct? It should be in meter cube. It is in liter. 1 liter is equal to 10 power minus 3 meter cube. This is the unit of volume. Okay, we have 50 liters. 50 liters is equal to 50 into 10 power minus 3 meter cube. So we got the answer in terms of meter cube. This is the volume value. That is what we are going to substitute. So 1000 into 50 into 10 power minus 3. Okay, what do you mean by 10 power minus 3? That is nothing but whatever the value we have, that divided by 1000. So if you have 10 power plus 3, okay, then whatever the value we have, that is into 1000. If it is 10 power minus 3, then whatever the value we have, that divided by 1000. So 1000 into 50 divided by 1000 will get cancels. So 50 kg. That's it. So we got the value of mass. This is how we are going to find the value of mass. See, this question may feel like it is very lengthy, but if you know the logic, okay, if you know the method, then everything will be easy. Now we got the value of mass. Substitute here 50 into what is the gravity value? 10. So that is 500 Newton. So from here we got it here. Now from here we are going here. So we got the value of F, that is 500 Newton into S. What is the value of S? 25. Okay. 25 5s are 125. How many zeros? 2 zeros. 12500 joules. We are finding the value of work done, right? So joules. So from here we got it here, correct? From here we are going here. So W is 12500 divided by time. What is the time value they have given? 5. 5 ones are 5, 25s are, that is 202500 watt. So this is how we are going to find the value of power. Question number 8. A pump is used to lift 600 kg of water from a depth of 75 meters in 10 seconds. Calculate the work done by the pump, power at which the pump works, and power rating of the pump if the efficiency is 40%. Okay, so power is different, power rating is different. Okay, power rating means power input we have to calculate. Here efficiency of the machine is given as 40%. Now we are not going to use the same method which we have learnt in the previous questions. So power rating is different. I will teach you how to do that one. So first we will write what are the given data. So mass is given as 600 kg, G is given as 10, then height or depth or displacement is nothing but 75 meters, then time is given as 10 seconds. So we have to find power, then power rating. Okay, power rating if it is 40% efficient. So first what we are going to find? Work done. First we will find work done, power, and then we will talk about power rating, how it is different from power. Okay, first work done formula will be Fs, correct? Force into displacement. Again here in this question they are not talking about any angle, so cos theta we are not going to use. F we don't have. How we can find the value of F? That is mass into gravity. So 600 into 10 into S, that is nothing but 75. So 600 into 10, that is 6000 into 75. If we multiply 450000, so what we are finding? Work done, so that will be joules. We can keep it like this, or 4.5 any value into 10 power 5 joules. See, in the textbook they have given like this. You should not confuse between this one and this one. That is why I am writing both the things. If you stop it here also, you will get full marks. So work done is done. So once you find the value of work done, what we have to do? Write the conclusion. Work done by the machine or a person, anything, is this answer. Then we will find power. Power is equal to work done by time. So if you get confused with this one, you can use this one also. Both are same. 450000. What is the time value they have given? 10 seconds. 10. So 1010. This will become, see, the same thing. 45300. What is the unit of power? Watt. See, in the textbook they will give it as 45 kilowatt. 45 is the zeros. What do you mean by 3 zeros? That is nothing but kilo. That is why they have written kilo. If you write this one only, then you will get full marks. Don't worry about textbook answers. Both are same only. Next. So this is the first one. This is the second one. What we are going to find, that is the power rating. Very important question. In previous question and all, it was 100% efficient. This question they have told 40% efficient. Listen. What is the efficiency formula? This is the efficiency symbol. Efficiency is equal to power output divided by power input. Okay, whenever they are talking about power rating, that means they are talking about power input. So write this one, power rating is equal to power input. So this is the efficiency formula, power output by power input. So they are talking about power rating, we have to find power input. So power input, if you rewrite the formula, power input is equal to power output by efficiency, correct? Power output, whatever the value we have got here, 45 kilo, correct? That is nothing but 10 power 3 divided by efficiency. Efficiency they have given as 40%. 40 divided by 100. Whenever you are substituting this value, it should not be in the form of percentage. So to remove percentage, we have to divide it by 100. 40 divided by 100, it is 0.4. 0.4. So 45 into 10 power 3 divided by 4, you will get the answer as 112,500. 112,500. Again, we are talking about power, right? It is also power. Unit will be watt only. In the textbook, they have given 112.5 kilowatt. Okay. So if you remove 1000 by here in this answer, we will get kilo. That's it. Don't worry about these two. If you write it in any form, you will get full marks. That's it. Question number 9. An ox can apply a maximum force of 1000 Newton. It is taking part in a cart race and it is able to pull the cart at a constant speed of 30 meters per second while making its best effort. Calculate the power developed by the ox. See, here in this question, instead of giving this one work done and time, they have given velocity. So first we will write the given data, then we will understand question. So first, what is given? Force, that is 1000 Newton, then velocity 30 meter per second. They are asking for power. Okay, what is the formula for power? Work done by time. To find work done, we have force and we required distance or displacement or height, but nothing is given. They have given velocity. How we can find power? So we have power formula. Okay, power formula as force into velocity. So this is one of the formula to find power. So how we got this formula? See, that how we got this formula is not required for this question. For your understanding, I will teach it here, but you don't have to do whatever I am going to teach it here. So you just calculate substitute the values and get the answer. So I am going to teach why we got power is equal to force into velocity. Listen, very simple. Power is equal to work done by time. Correct. This is the original formula. Work done is equal to force into displacement by time. Correct. So this time I have written as it is. Work done is nothing but force into displacement. I'll write force as it is. What is displacement by time? That is nothing but velocity. So this is how we got the formula. So you don't have to write this one in the exam. If you know this method, this is how we derive the formulas, different formulas. If you understand this one, directly substituting the values, we will get the answer for power. Force 1000 Newton. So it is in the SI units. We can directly substitute it 1000 into velocity. What is the SI unit of velocity? Meter per second. So it is in its SI unit. No need to convert it to any other value. So that is 1000. 30 into 1000, 30,000 watt. So if you write this one, you will get full marks. In the textbook, they have given like this, 30 kilowatt. Very simple question. Question number 10. The power of a motor is 40 kilowatt. At what speed can the motor raise a load of 20,000 Newton? Okay, very simple question. If you know the previous question, then this question is very simple. So they have given power value itself, that is 40 kilowatt. They have given force, that it has 20,000 Newton. They require velocity or speed, anything is fine. Okay. So what is the formula? Power is equal to force into velocity. We require velocity, so that will become power by force, correct? So velocity is equal to power by force. So what is the power value? 40 into 1000 divided by 20,000, correct? So 40 into 1000, that is 40,000 divided by 20,000. 4 zeros get cancelled. 2 ones are 2 twos are, that is nothing but 2 meter per second. That's it. Very simple. See, kilo is nothing but 1000, correct? Kilo. That is why I have replaced with 1000. Very simple question. Question number 11. Rajan exerts a force of 150 Newton in pulling a cart at a constant speed of 10 meter per second. Calculate the power exerted. Very simple question. Two questions we have solved previously. If you know that, then this is a very simple question. So they are asking for power. We need to calculate power. What are the given data? Force 150 Newton, then velocity or speed as 10 meter per second. Okay. So power is equal to F into V. F is nothing but 150. V is nothing but 10. 150 into 10, 1500 watt or 1.5 kilowatt. That's it. So here 1500 watt, for this one only you will get full marks. In few textbooks they have given like this. That's it. Question number 12. A boy weighing 350 newtons climbs up 30 steps, each 20 centimeter high, in 1 minute. Calculate the work done and power spent. Very simple question, but there are some calculations. So apart from the questions they have asked, we have to calculate something else. First we will write the given data, then we will understand everything. So 350 Newton, what is that? That is nothing but force. Next, time is given. Time, it is given as 1 minute. So we have to convert into 60 seconds. Next, so they are talking about 30 steps. One step is 20 centimeter height. Listen, like this they have 30 steps. So one height is equal to, one step height is 20 centimeter. So how many steps we have? 30 steps. So 30 into 20, we will get distance, some distance, that is nothing but displacement. Correct. So we require displacement to find work done. We have force, we have to find the displacement, that is nothing but 30 steps. One step height is 20 centimeter. We have to find the complete height of 30 steps. So 30 steps they have given, 30 into 20 centimeter. Correct. That will be 600 centimeter. Correct. What is the unit of displacement? Meter. It is in centimeter. First convert into their SI unit. If you substitute 600 also, you will get some answer, but that will not be the correct answer. So if first step is only wrong, everything will be wrong. That is why whenever you are substituting any value, make sure it is in its SI unit. 600 centimeter, that is nothing but 6 meter. Okay, now we have to find work done. Correct. First is work done. Work done is equal to F into S. What is F value? 350. What is S value? 6. So 350 into 6, that will be 2100 joules. That is the unit of work done. Second, we have to find power. Correct. Power is equal to work done by time. What is the value of work done? 2100 divided by time. How much time it is taking? 60 seconds. So time should be in 60 seconds. Only when we are finding energy value, time will be in hours. Okay, time should be in hours. If apart from energy, whatever we are calculating, time should be in terms of seconds. So 210 divided by 60, that will be 35 watt. That's it. Question number 13. It takes 20 seconds for a person A of mass 50 kg to climb up the stairs, while another person B of same mass does the same in 15 seconds. Compare their work done and power developed by the person A and B. Okay, listen, first we will write what are the given data. Mass of A is equal to 50 kg, and they have mentioned person B mass also, it is 50 kg. Okay, time taken by the person A, okay, TA is 20 seconds, and time taken by the person B is 15 seconds. So we have to compare their work and also power. Listen, whenever the word compare comes in the question, that means we have to find the answer in the form of ratio. Keep that in mind. Okay, note it down somewhere. That compare means you have to find the answers in terms of ratio. So first, okay, we have to find the work done. We have to compare the work done. So that is nothing but work A is to work B we have to find. This is the first task. Okay. Listen, very simple concept. Do you think work done depends upon time? What is the formula for work done? Force into displacement. Do you think there is time in that formula? Work done. So listen, work done is equal to force into displacement. In this formula, do you see any time? No, right? So person A, okay, is doing some work, any work. Don't worry about this question, any question. Okay, person A is doing some work and person B is also doing the same work. If person A takes 1 hour and the person B takes 20 hours to do the same job, okay, what is the work done by person A and person B? So it does not depends upon time. So if it takes 1 hour or 24 hours, 40 hours or 50 hours, work done will be same. Work done will be same. So for first question, compare the work done. What do you mean by comparison? That you have to write it in the form of ratios. Work done by A is to work done by B will be same. When the answers are same, you have to write the answer as 1:1. This is your answer. You got my point? Work done does not depends upon time. Okay, if it is 1 hour or 2 hour, person A is taking 20 seconds, person B is taking 15 seconds. So what? It does not depends upon time. So work done does not depends upon time. You can write it in the bracket. Work done is independent of time. Independent of time means it does not depends upon time. So if it takes 5 hours or 6 hours, the work done will be same. What is the comparison? So comparison means you have to write it in the form of ratios. So that is 1:1. When the work done is same, it is 1:1. Then we have to talk about power. Okay, we have to talk about power. PA is to PB we have to find. Okay, what is PA? PA is nothing but WA by TA, correct? Work done by time is to work done by B and time taken by B. We know work done by A and work done by B are same. So here we have to take it as 1. TA value is 20 is to work done by B is also 1. TB will be 15. You got my point? Listen. Work done by A we have taken it as 1 and work done by B we have taken it as 1. Why? We got 1:1, correct? So TA is 20, TB is 15. What do you mean by ratio? Ratio means 1/20, okay, whatever the value you have first, that you write it as it is, divided by the second value, 1/15. So that is the meaning of ratio, right? So once you have this one, so two fraction, one fraction divided by one more fraction, you can write this as 1/20. Instead of division, you can take it as multiplication, then take the reciprocal. 15 divided by 1. 1/15 will become 15/1. Why? Because division is becoming multiplication. So 5 3s are 5 4s are. Numerical value we have 3, denominator we have 4. So PA is to PB will be 3:4. That's it. What do you mean by PA and PB? Power spent by the person A, power spent by the person B. See, power spent by the person A is only 3 and power spent by the person B is 4. It is not the exact value, it is in the ratio. What do you mean by that? Listen, very simple thing. Person A will take 20 seconds to do one job. Person B will take 15 seconds. So if I have to do any job by taking less amount of time, that means I have to put more power. I have to put more power. Person B is doing the job quicker, correct? That means he has spent more power compared to A. So this is how you understand the meaning of the ratio. So in the exam, you are not going to write any of those things, only the final values are enough. Question number 14. A boy of weight 40 kgf climbs up the 30 steps, each 20 cm high, in 4 minutes, and a girl of weight 30 kgf does the same in 3 minutes. Compare the work done and power developed by them. Very simple, related to previous one, but in that question we got the answer for work done directly. Here we are going to calculate it. So first we will write the given data. So mass of boy is 40 kgf, mass of girl is 30 kgf. correct. Time taken by boy is 4 minutes. Time taken by the girl is 3 minutes. And we have how many steps? 30 steps. One step is equal to 20 centimeter. We have to compare the work done and power, correct? What do you mean by comparison? That is in the form of ratio. So work done by the boy is to work done by the girl. We have to find power spent by the boy is to power spent by the girl. We have to find. Okay, first we have to find the work done, correct? Here how we can find the work done? Work done is nothing but force into displacement. How can we find force? Mass into acceleration due to gravity. G, if it is not given in the question, we can take it as 10. So first work done is equal to F into S. First we will talk about the boy. Okay, work done by the boy is force into displacement. So what is force? Force they have not given directly. So mass is given 40 kgf into 10. We will get the answer in terms of force. Displacement. Okay. Displacement is nothing but the 30 steps, correct? One step is 20 centimeter. Then 30 steps is equal to 30 into 20. So S value, okay, S is equal to 30 steps into 20 centimeter. That will be 600 centimeter. Displacement always should be in the form of meters, correct? So this is nothing but 6 meters. So this S value we have to substitute here. 4 6 are 24, 2 zeros are there. Work done by the boy is 2400 joules. Okay, work done by the girl, the same method, F into S. F, what is F? Mass into acceleration due to gravity. Mass of the girl is 30 into 10. We will get the answer in terms of Newton. Then displacement for boy and girl, they are climbing 30 steps, right? So displacement will be same. Here also it is 6, 3 6 are 18, 00 joules. That's it. Now we got the separate answers, correct? But we want it in the form of ratios. That is what we are going to find. So we have to find work done by the boy is to work done by the girl. So it is in the form of ratio. What do you mean by the ratio? That is nothing but WA by work done by the boy divided by work done by the girl, correct? What is work done by the boy? That is 2400 divided by, so this is separate. Okay, this is the final answer we are getting. Work done by the girl is 1800. 2 zeros get cancelled. 6 3s are 6 4s are, that is nothing but 4:3. Okay, whatever the value we got in the numerator, that we'll write it first. Denominator value will be written in the second place. Next, so WB is to WG is equal to 4:3. This is the ratio for the first one. Second one, we have to talk about power spent by the boy and power spent by the girl. So like this we can calculate the power spent by boy and girl separately, then we can substitute like this, or else we can directly substitute the values and get the answer. In both the cases we are going to get the same answer. So we will directly write the answer. Power spent by the boy is to power spent by the girl is nothing but PB by PG, correct? Power of boy and power of a girl, not power of a boy, power spent by the boy. So power spent by the boy is nothing but work done by the boy divided by TB, correct? Work done by the boy and time taken by the boy. What is power spent by the girl? Work done by the girl divided by time taken by the girl is equal to, see, don't use this value, you will get confusion. Directly use this value only. Work done by the boy is 2400 divided by time taken by the boy, that is 4 minutes. It is in the form of minutes, we have to convert into seconds. 4 minutes into 60 seconds. 4 6 are 240 seconds divided by work done by the girl is 1800 divided by time taken by the girl, that is 3 minutes. 3 minutes in the form of seconds. 3 into 60, 180. So first divide these two, we can simplify it here, right? 1 0 1 0 get cancelled. So 24 ones are 24 tens are. So we have here in the numerator 10 by 1, correct? In the denominator again 0 0 get cancels. 18 ones are 18, tens are 180, so 10. So again here we have 10 by 1, correct? So when you have in this kind of answer, don't get confused, write it in a simpler way. See, how can we get it in the form of ratio? First write the first value, first fraction as it is. Instead of division, we will write multiplication. Then here we have 10 by 1. When you take multiplication instead of division, you have to take the reciprocal. So 10 by 1 will become 1 by 10. So 10 into 1, 10, divided by 10 into 1, 10. So both the values are same. 0 0 get cancelled, 1 by 1. So power spent by the boy and power spent by the girl is same. So 1 by 1 is nothing but 1 is to 1. That is power spent by the boy and power spent by the girl. That's it. Question number 15. A man raises a box of mass 50 kg to a height of 2 meters in 20 seconds, while another man raises the same box to the same height in 50 seconds. First one, compare the work done and the power developed by them. Second one, calculate the work done and the power developed by each man. Take gravity value as 10. Okay, very simple. First we will write the given data. First, mass of man A is equal to 50 kg. Okay, here in this question, mass of the person B, okay, another person is not given. So take that mass as same. Mass of another person is also 50 kg. Then height they have given, correct? Height is nothing but displacement, that is nothing but 2 meter. And then time taken by the person A is 20 seconds and time taken by the person B is 50 seconds, correct? Next, what we have to calculate? First we have to compare their work done. WA is to WB, first we have to find, okay. Then PA is to PB. Then second one, we have to find the work done separately, powers separately. So we have to calculate WA, WB, PA, power spent by B. Okay. First we will find work done by A and work done by B ratio. Then we will go for all the remaining things. Okay. What do you mean by work done? Work done is nothing but force into displacement. We know H and displacement both have 2 meter. If it is person A or another person B, they have both same mass and they are lifting the box to the same height, that is 2 meter. So if mass is same and displacement is same, then how can we find force? Mass into gravity, that is also 10. So mass is same, gravity value is same and displacement, all the three values are same. Then work done by A and work done by B, okay, both are same, correct? So then work done by A is to work done by B will be equal to 1 is to 1. Because all the three value for work done, what is required? Force and displacement. Force we can find with the help of mass and gravity. All the three values are same. Then we are going to get the value of work done as same for both the persons. So that is why I have written 1 is to 1. But they have given two different time, correct? Work done does not depend upon time. See the formula. In work done formula, do you see any time? No. So work done does not depend upon any time. So that you can write it in the brackets. Okay, what you are going to write in the brackets? Work done does not depend upon time, or else you can write it as work done is independent of time. Anything you can write. Next, we'll talk about power spent by A and power spent by B. See, whenever something is in the ratio, you can write it as fraction. If something is in the fraction, you can write it as ratio. I'll give you an example. See, PA is to PB, you can write it as PA by PB. Okay. Now, what is PA? Power spent by the person A. Okay, that depends upon work done by A divided by time taken by A. That is the formula for power, right? Power is equal to work done by time. So we are talking about person A, work done by A and time taken by A. In the same way, work done by B and time taken by B. We know work done by A and work done by B is same, so we can take it as 1. So 1 for work done by A, time A, TA is 20 seconds, divided by work done by B is 1, time taken by B is 50 seconds. So this is nothing but 1 by 20 into 50 by 1, correct? 0, 0 get cancels. What is remaining? 5 into 1, 5 in the numerator, 2 into 1, 2 in the denominator. So power spent by A is to power spent by B. See, initially the ratio we have converted into fraction. Now we have fraction, we will convert it into ratio. Write the first numerator first is to denominator second. That's it. So this is how we'll compare power spent by A and power spent by B. What do you mean by comparison? Write it in the form of ratio. Next, second one, they are asking us to find work done by A, work done by B, power spent by A, power spent by B separately. So work done by A depends upon two things, force and displacement. Here force is not given. How can we find force? Force is nothing but mass into G value, correct? What is mass? 50 into G value 10. So mass into G, we will get the answer in terms of force into displacement, that is 2, correct? Displacement is 2 meter. So 50 into 10, 500, 500 into 2, 1000 joules. Next, we will find work done by B. See, for work done by B, the same formula, and mass is same, gravity value is same, and the displacement value is also same. So we will take the same value, 50 into 10 into 2, that is nothing but 1000 joules. Okay, now we will talk about power spent by person A. Power spent by person A depends upon two things, work done by A and time taken by A. So work done by A is 1000 joules, correct? That is 1000 divided by time taken by A is 20. For 2 zeros, 2 0 get cancelled, 2 1s are 2 50s are, so that is 50 watt. Okay, next power spent by B, same method, power work done by B by time taken by B. Work done by B is again it is 1000 divided by time taken by is 50, 0 0, 5 1s are 5 20s are, so that is 20 watt. See, if you know the formula and if you know how to get the ratio values, then everything is very easy. These kind of questions, see, they are not going to ask this question as a one question. They can split this question in any way. If you know the method, if you know what you mean by comparison, how to find work done, what is the condition for work done, make sure all the time work done is not depending on time. According to the formula, work done will not depend upon time, but power depends upon time. Our last question. A boy takes 3 minutes to lift a 20-liter water bucket from 20-meter deep well, while his father does it in 2 minutes. Compare the work and the power developed by them. Second one, how much work each does. So they have given density of water and gravity as 9.8. It is very much important. Gravity they have given as 9.8. In all the questions they have given 10. Okay, first we will write the given data. So in this question we are talking about boy and his father, correct? Now they have given 20 liters of water. What is that 20 liters of water? That is not the mass of the water, that is the volume of the water. So volume of the water is 20 liters. Next, height is given, that is 20 meters height. Height is nothing but yes, that is 20 meters. Then time taken by the boy. Time taken by the boy is 3 minutes. Time taken by the father is 2 minutes. G is equal to 9.8. Don't worry about the unit. So we have to compare work and powers, and we have to find how much work is done. So to find work done, we need mass, correct, or force. If force is not given, we need mass, correct. Whenever the volume of any liquid is given, like 20 liters, 50 liters, we have to get the value of mass. So how to find the mass? Using volume. This I have taught in question number 7. Please go to question number 7, learn that method and come back, because here it is going to take some time. So I am going to write the answer directly. If volume is equal to 20 liters, mass will be 20 kg. You have to show this conversion in the exam. So that is why I am telling you, in question number 7 I have taught you how to convert this volume into mass. Very simple method. You already know, you have learnt in 8th and 9th standard. Very simple logic. Okay, now we'll go for the question. We have to compare work done, correct. Now, so work done by the boy is to work done by the father. So here they are lifting same volume of water with the same height, correct, same volume of water with the same height. So force and the displacement both remain same, and work done does not depends upon time. So boy is taking 3 minutes and father is taking 2 minutes. Work done does not depends upon time. If boy takes 5 minutes and this father takes 1 minute also, work done remains same. Why? The volume of water whatever you are lifting and the height remains same, correct. So work done by the boy and work done by the father will be same, 1:1. What you are going to fill in that bracket? Work done does not depends upon time, or work done is independent of time. Next we will find power ratio. Power spent by the boy and power spent by the father. Okay, for this one, okay, the ratio we can convert into fraction. Power spent by the boy, power spent by the father is equal to work done by the boy by time taken by the boy by father. We are talking about father now. So work done by the father, time taken by the father. Work done by the boy and work done by the father are same, correct. So instead of WB and WF, we will replace it as 1. Next, time taken by the boy is 3 minutes. Okay, here in when we are comparing any two quantities, okay, any two things, any values, okay, if we are comparing, if you convert that into SI unit or if you substitute this value directly, okay, you will get the same answer. Okay, only when you are doing the comparison. If you are not comparing it, if you are just finding power spent the boy, then you have to convert this time into SI units to seconds. Now here anyhow we are comparing, so unit and unit will get cancels. We don't have to convert it. If you convert and substitute also, you will get the same answer. Don't worry. Now I am not converting it, but whenever you are trying, convert this one into SI units. 3 minutes is nothing but 180 seconds. 2 minutes is nothing but 120 seconds. So time spent by the boy, I will take it as 3. While you calculating, okay, you take it as 180 seconds. We both get the same answer. So that is 3. Then we are talking about work done by the father, that is 1. Then time taken by the father is 2 minutes. So this is nothing but 1/3. Instead of division, I will take it as multiplication. Then I will take reciprocal. This becomes 2/1. So see, now I can write this one as 2/3. Correct? 2 into 1, 2. 3 into 1, 3. See, initially the ratio I have converted into fraction. Now I have fraction. I will write it in the form of ratio. So PB is to PF. Power spent by the boy is to power spent by the father is equal to, write the first numerator value first, then is to denominator value. That's it. Okay. Next we have to find work done by each. Correct? Work done by the boy is force into displacement. We don't have force value. How can we find the force value? Mass into gravity value. So what is the mass? That is 20 kg. What is the gravity value? See, here in this question they have given 9.8. So we have to take 9.8. Don't take 10 all the time. Displacement, it is 20 meters. So here we are not comparing any values, right? So we have to substitute all the SI units only. So here while doing the comparison, you don't have to convert into SI units. You can go directly, you will get the same answer. So 20 into 20, 400, 400 into 9.8, that will be 3920 joules. Okay, you can write this as 3.9 kilojoules. If you write it here, if you leave it here only, okay, 3920 joules, you will get the full marks. Now listen, this is the work done by the boy, correct? Next, work done by the father. Listen, work done by the boy and work done by the father, that is same. That is what we have mentioned here, right? Because they are taking different time, but work done does not depends upon time, correct? So work done by the boy or work done by the father will remain same. So work done by the boy and work done by the father is 3.9 kilojoules. That's it. So now we have finished all the numericals in work energy power part A, correct? So first we have learned the concept work energy power. What is work energy power? What are the concepts that is there in work energy power? Then we have solved all the theory questions one by one, and now we have solved all the numericals. The concept part of work energy power and all the exercise theory questions videos are available in the description box. First learn that, then you will understand all these things in a proper way, because for the exam both are important, both theory and also the numericals. Thank you.